Hi, next we discuss about structural modeling in VHDL. An entity is modeled as a set of components connected by signals, that is set as a netlist. The behavior of the entity is not explicitly apparent from the model. The component instantiation statement is the primary mechanism used for describing such a model of entity. A component instantiation in a structural description must first be declared using a component declaration. In hierarchical design, a larger design entity can be called a smaller design unit in it. This process a hierarchical structure. This is allowed by a faster VHDL called component installation. The syntax for call a component name, port declaration, input and output whatever, and end component. Here we discuss about two examples. One is for you implement to full adder, another one 4:1 multiplexer. If you implement to full adder, first you want to write the submodel of off adder. Using this off adder, you can implement all top level modelings. So here off adder A and B is input, output sum and carry 1. The sum should be input of your other off adder, and here your other input should be C. Here you can getting a sum is a full adder sum. The carry should be getting all operations, that is your exit carry. The same like that multiplexer. So first you want to implement 2:1 multiplexer. Using this 2:1 multiplexer, you can implement 4:1 multiplexer or 8:1 multiplexer or whatever. Okay, but basically want to implement if 2:1 multiplexer, your selection line is considered as S0, and second one you can consider as S1. Okay, S0 and S1 there are 4 combinations, and the corresponding inputs are and following by outputs. First one, you want to implement your full adder. So before that you want to implement your off adder, that is your sub programming, sub model. So what you discussed already, the same like that. First you want to implement, call your all library files. Then we discuss about entity A, B in ST_underscore logic, sum and carry entity. You can using that. This code should be implemented through the data flow modeling. S equal to A XOR B and C equal to A and B and end entity. Okay. The same like that you want to implement the OR operations. First you want to write all library codes, call your what are the inputs are X and Y and in ST_underscore logic, Y is Z is out ST_underscore logic in architecture and end architecture. Now we want to call upon all the submodel off adder as well as OR get. So this is your top modeling of VHDL code. First write your call your library files, and first you want to declare what are the input and output variables. So full adder we will get 3 inputs and 2 outputs. FABC input ST_underscore logic, FS and FCA your output. Next one you want to call each both 2 blocks. One is for off adder, another one for OR get. So component H is a model name of your off adder, and the port mapping should be what you declare the same like that you want to declare here. A, B input ST_underscore logic, S and C is your output ST_underscore logic. You want to close this component. This is your one component. Other component should be OR gate. Component R1 X, Y in input ST_underscore logic, Z is output ST_underscore logic, and the end component. Now we want to port map the signals. We want C1, C2 and S1 begin. FA is your instance names. You want to know the project name. FA is off adder. So port map of now you can, if what your order, the same order you can implement your declarations. So here FA, FB and S1, C1, sum 1 and carry 1. So next one call upon second one off adder 2 HA port mapping S1, C1, S and C2. Now we want to implement your carry. So ORG is instance name, OR1 is your project name of your OR gates, port map C1, C2, CA, semicolon, so and FA. Thank you.